do we train this model? Now recall what we discussed yesterday, that we have a data which is split into two parts, 70-30, and then the model is built on the training, then applied on the testing, and then you get the result, and then evaluation, and then this whole cycle repeats. OK, now same thing is done. Similar technique is done on the textual data also. Now here there's a slight difference. Now, can anyone tell me what are the challenges that we have with respect to textual data? See, when we are talking of text data, the challenges are multiple. OK, number one is you need to convert the text into numbers, because machines cannot read text like the way we do. OK, so first thing is, how do you convert a machine? How do you convert a text into numbers? OK, that is the first challenge. The second challenge is, how do you format the data, the text data? OK, now what are the different formatting challenges that we have? Number one, there could be spelling mistakes. OK, for example, I have a word called machine. So MACHINE, that is a correct spelling. Now suppose I have another word which is MACINE, machine. OK, so the H is somehow missed, or maybe there's a different format of the word. OK, MAHICME. So there could be spelling mistakes. OK, so these are the different challenges. So you need to spend a lot of time in rectifying these mistakes and correcting them. There are techniques and there are libraries to do this. But what I'm trying to say here is you need to get all these things fixed before applying these language models. Now, what are the other challenges? So that is what I have listed here. So the training process involves text pre-processing. Now the pre-processing steps are, I've just listed a couple of them, stop words. Now some libraries take stop words, some do not take stop words. They do it internally, they do the processing. Now what stop words means is that in a given sentence, not all words are not all words make sense. OK, let's take an example. I have a sentence called this is a let's say this is a new product. Let's say I have a sentence like this. This is a new product. Now I want to analyze what kind of a sentiment is this. Now, do you think I require all the words to make sense out of this? Or can I take only selected words? OK, now what are the words that I can remove from this? So this does not make any real meaning. Is does not make any real meaning. I can ignore. So what is my sentence now? Out of the 5 words, it has now only 2 words. What are they? New and product. So what is the advantage of doing this? I have reduced the dimension from 5 and brought it to 2, which is a significant reduction in the the dimension. OK, so this is called stop words. So take away text which is not required, only regain those texts which you wanted, and then work only on that. Now the corpus comes with a predefined set of values. You can also have new words which you think are stop words. For example, language specific words you can use and define them in the list of stop words. Then you have other techniques like tokenization, lemmatization, and vectorization. So these are techniques to convert data into numbers. But there is another word called lemma. So lemmatization means that you want to bring a word into its root form. OK, for example, I have a word called programmer. Then I have a word called programs. Then I have a word called programming. Okay. Now, what is the root word for all these things? The root word for everything is a word called program. So if I have a text which contains a mixture of all these words like programmer, program, programs, programmer, etc. So if I bring it to only one base word, which is program, does it solve any purpose? Is it helpful? Yes, because it will again do the reduction in the dimension. So let's say there are 20 occurrences. So 20 occurrences now is brought to only one occurrence because the context is the same. So I can still get a lot of meaning out of this. So this is called lemmatization. So these are some pre-processing techniques that we use for on the textual data. Okay, now the other then training process. So one is text pre-processing, then optimizing the weights. So if you recall, I told you some time back that there are 11 weights on the simple model. So how we can optimize those weights? So that is called as the fine tuning of the models. Okay, so these two are pretty much similar. One you're optimizing the weights, the other is the parameter optimization. Okay, same thing. Then what are the different types of models? So one is called as the recurrent neural networks. Then this has also an extension which is LSTM. So these models usually are for text related stuff. You want to predict the next word, you want to predict the next sentence, okay, etc. So it is used for these kind of predictions. Then the other models that we have for generating images are called VAE, variational autoencoder. So autoencoder and VAE, variational autoencoder. So they are used for generation of text and images. Now the ChatGPT that we saw some time back for prompting. So that uses something called as a transformer model, which is this one. Okay. So transformer models are very, very sophisticated, very complex models, which uses a two-tier technique. So here you have an encoder technique, and then here you have a decoder. Okay, now each encoder and decoder. So this is encoder and this is decoder. So when you pass the data into the encoder layer, so encoder has around 18 layers. So 1, 2, 3, 4, 5 till 18. So it processes the input text. And once the processing is done by converting it into numbers and getting, it's a very complicated process. So it does a lot of calculation, matrix multiplication to find out what is the significance of these words. And then after it finished processing, it will pass on the information to the decoder layer. So decoder layer also has 18 layers. So where it will find the relation of these words and then give the response. Okay, so this is a transformer model which is used in ChatGPT and other language models. So, ChatGPT and other language models. Okay, so these are the training processes and how these networks are built. Thank you, everyone.